Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0812, indicates an issue with the transmission range switch specifically related to the ATP R switch for the Honda Civic model years 2011 to 2015. This code suggests a problem within the electrical circuit associated with this switch rather than mechanical components inside the transmission. An essential point to note before proceeding with any troubleshooting is to record all freeze data and conduct a thorough review of the general troubleshooting information using the Honda Diagnostic System, HDS. This systematic approach ensures that the technician is briefed on the latest diagnostics and helps in pinpointing the electrical failures leading to the code. The ATR switch plays a critical role in communicating the position of the transmission range to the powertrain control module, PCM. Identifying the root cause of any signal failure is crucial for ensuring the vehicle's operational accuracy and safety. The transmission range switch is integral to the proper operation of the automatic transmission system. It interprets the vehicle's gear status and communicates this information to the PCM, ensuring that the engine and transmission work in harmony. In the Honda Civic, this switch is located in close proximity to the transmission, connected via a 10-pin 10P connector. The ATR switch is primarily responsible for reviewing whether the vehicle is in reverse gear and transmitting this data via its electrical signals. If there's a malfunction in this circuit, the PCM may receive incorrect data, leading to performance issues or even safety hazards. Therefore, the correct functioning of both the transmission range switch and ATR switch is crucial for the vehicle's transmission system to operate reliably. The predominant cause for DTC P0812 is an electrical circuit issue that prevents proper communication between the transmission range switch and the PCM. Unlike mechanical failures within the transmission, this condition exclusively arises from electrical or wiring problems. One possibility includes an intermittent fault in the signal processed by the ATR switch. This could lead to temporary malfunctions, making diagnostics complex. Additionally, the underlying issue may stem from a failed transmission range switch itself, impacting the system's efficacy. Each of these potential causes highlights the importance of thorough testing and electrical checks during the troubleshooting process, ensuring all components are fully operational before considering more significant repairs. The symptoms of DTC P0812 can manifest in several observable ways. First, drivers may notice incorrect gear indications on the dashboard, particularly when attempting to shift into reverse, leading to confusion and potential driving hazards. Next, transmission slipping might occur, where the vehicle hesitates or fails to engage properly when the shift lever is moved. Another key symptom includes the illumination of the check engine light, CEL, which serves as an alert to underlying malfunctioning systems. These symptoms not only compromise driving safety, but can also contribute to further mechanical damage if left unaddressed, thus necessitating prompt diagnostic and remedial action. The first troubleshooting step for DTC P0812 begins with turning the ignition switch to the on position, labeled as II. This allows power to be transmitted throughout the electrical systems, enabling diagnostic checks. Subsequently, the shift lever must be moved to the reverse position, R. Utilizing the Honda Diagnostic System, HDS, the technician must verify the ATR switch signal reflected in the AT data list. If the HDS indicates that the ATR switch is on, this means the signal is functioning correctly. On the contrary, if the signal is off, it indicates a problem, necessitating further investigation into subsequent troubleshooting steps. This step is crucial as it determines the immediate state of the ATR switch and sets the tone for the next actions. In the second troubleshooting step, the technician must first turn the ignition switch to the lock position, labeled as 0, to ensure the electrical systems are powered down safely. Following this, the technician will disconnect the transmission range switch connector, 10P, to prepare for direct terminal testing. A jumper wire will be used to connect terminals A and B in the 10P connector. Terminal A refers to the transmission range switch terminal number 9, white wire, and terminal B connects to the body ground. This creates a direct path for testing the circuit integrity of the ATR switch. Once the jumper wire is connected, the next step involves turning the ignition switch back to the on position to check for any signals from the ATR switch through the HDS. The third troubleshooting step further isolates the potential issues in the electrical circuit. Start by again turning the ignition switch to the lock position, 0, to prepare for the checks. Next, the SCS line must be jumped using the HDS, initiating a diagnostic state that helps assess the simpler circuits more accurately. Disconnect the PCM connector B49P as part of this step to prevent any interference. It is crucial to check for continuity between the designated test points defined in the troubleshooting guide. Test point 1 checks the PCM connector B49P at number 25, white-green wire, against test point 2, which connects to the body ground. This wiring check confirms whether there's an active pathway, central to determining if any wiring issues exist in the ATP-R line. After completing the appropriate repairs indicated by previous troubleshooting steps, it is critical to perform a repair verification process. Start by reconnecting all the connectors previously disconnected during troubleshooting, ensuring all connections are secure. Next, utilize the HDS to clear the diagnostic trouble codes, preparing the PCM for new data collection. It is then vital to test drive the vehicle under controlled conditions with the shift lever in the reverse position for a brief initial period, ensuring speeds do not exceed 3 miles per hour, 5 kilometers per hour. After this, increase the speed beyond 3 miles per hour, 5 kilometers per hour, and continue monitoring the response of the vehicle during this second driving phase. Finally, the HDS should be consulted again to check the OBD status to determine if the DTC P0812 has been resolved effectively. In summary, DTC P0812 emphasizes the importance of a robust approach to diagnosing potential electrical issues within the transmission range switch circuit. Primary causes include electrical circuit problems and intermittent faults, underscoring how critical thorough circuit checks are when diagnosing this DTC. By resolving these issues, potentially harmful symptoms like incorrect gear indications and the check engine light being illuminated can be addressed effectively. A complete understanding of component locations and functionalities is equally essential, ensuring technicians can locate and rectify issues efficiently. By following the detailed troubleshooting steps outlined, technicians not only improve diagnostic speeds, but also enhance overall vehicular performance and safety. Please like and subscribe to the channel. See you next time.